Hello and welcome back. Today we're going to take a look at another section of the IMAT topic questions for physics. Today we're taking a look at some of the questions in torque and moment. Here we have in question 14, it says a uniform bar of length 2 meters, so the whole length is 2 meters, and a weight of 1,000 newtons at its center, has its center of gravity at its center. Okay, so the bar is pivoted and it has a weight of 200 newtons in that position shown. What is the weight needed at P, so at this location, that is needed to balance the bar? Okay, so here's the deal. First of all, the moment that is going to be created on the left side, we have one moment because of this 200 Newton weight, but also we have another moment that is going to be applied from the center of gravity. We can assume it's at the center here to down below, and that's due to the weight of the bar itself. We can just call that the weight of the bar. And we can calculate the moments of these two things. And since the 200 newtons and the weight of the bar are pointing in the same direction, they create the same sort of moment. And so we're going to go ahead and calculate the moment of this 200 to the pivot, which is going to be 200 multiplied by, a lot of people make a mistake of saying, they forget that this is up until here is not 2 meters. It's 2 meters minus that 0.5. So the distance of the 200 Newton to that pivot there is actually 1.5 meters. So 200 times 1.5, add it to the moment of the bar itself, which is 1,000 newtons. That's the weight of the bar, multiplied by its distance. If we assume this is the center to that pivot, we can say it's 0.5 meters. And this will be equal to the moment that has to be generated on the right side, which is the P, that's the force, multiplied by its distance to the pivot, which is 0.5 meters. So here we have this equation that we need to solve. We can assume that this is like 3 over 2, and 200 times 3 over 2 is going to be, you can cancel the 2 and the 200, that gives you 100. So the answer is 300 plus 1,000 times 0.5, which is just 500. It's kind of like halving it. Whenever you multiply by 1/2 or 0.5, you just divide the number by 2. And this is equal to P times 1 over 2, which 0.5 is the same as 1 over 2. So if you add 300 to 500, you get 800. And now you can multiply the 2 by the 800, and P will be equal to 2 times 800, which is 1,600 newtons. So the answer is D. All right, let's go ahead and take a look at the next question. This one is about the law of gravitation. It ended up in this part by some sort of chance. But anyways, we're going to go ahead and do it. So they're saying that the law of gravitation, which is one of the 3 main constituent forces in physics, is defined by this rule over here. They're saying the gravitational constant is that the mass of the Earth and the Moon is given. So this is your M1, that's your M2, and this is R. You just have to calculate this using the formula that's given. So F is going to be G, what's 7 times 10 to the power of negative 11, multiplied by M1, which is 6 times 10 to the power of 24, multiplied by M2, which is 7 times 10 to the power of 22. And this gets divided by the radius to the power of 2, so 4 times 10 to the power of 8 to the power of 2. Now, here's what you have to keep in mind. A lot of people, this is really simple. You're plugging in the formulas. A lot of people don't know how to calculate numbers without the calculator. So, you're used or accustomed to using the calculator in the A-level or the GCSE course, and you might not know some of the hand calculations. And that's what actually makes this question quite difficult. But it's really simple. So if you multiply, some of the numbers, you'll understand what I mean. Let's kind of try to simplify this. First, I'm going to simplify the scientific notation on the top. So I have 10 to the power of negative 11 plus 24 plus 22. That's because of the law of exponents. If you have 8 to the power of, for example, m times 8 to the power of n, if they have the same base, like 10 over here, you can add their powers. Anyways, what I'm going to get over here now is times 10 to the power of 24 plus 22 is 46, and 46 minus 11. So these two are going to add up to 46. If you subtract them by 11, you get 45 minus 10, positive 35. And then you have the numbers there. So you have 7 times 6 times 7. Don't multiply them just yet. On the bottom, you have to, rise that to the power of 2. 4 times 10 to the power of 8 gets raised to the power of 2. So you get 16 times 10 to the power of 16. Because 2 times 8 is 16 and 4 to the power of 2 is 16. So now that you have this, you can technically first subtract these powers, because they're getting divided. So you can write that as times 10 to the power of, what's 35 minus 16? Well, that gives you 25, and 25 minus 16 is minus 19. A lot of people would assume that the answer is going to then have positive 19 as its final answer, so they would choose A. But we don't know yet for sure. So we have to cancel out ED and C for sure, because there's no way we're going to get an answer in those ranges. However, if you multiply 7 by 6, well, 7 times 6 times 7, and then divided by 16. First of all, we can also simplify the 6 by 16. Divide both sides by 2, you get 3 on top, 8 on the bottom, and now there's no further simplification. So 7 times 3 is going to be 21, and 21 times 7, you have to calculate that. So it's going to give you 7 times 1 is 7, 7 times 2 is 147. So you have 147 divided by 8. And, if you kind of sort of assume something for yourself, you can say, for example, let's say you had like 200 divided by 10, right? This is just some assumption. You're going to get a 2-digit number, right? You're going to get like 20. The same thing happens here. You're going to get a 2-digit number, probably like something in, like similar to the answers we have, like 18 point something. The point is, because you get a two-digit number, according to the rules of scientific notation, you can add that power to the 10. So you're going to get 10 to the power of 20 anyways at the end, whatever the answer may be. So my guess is the answer is actually B. In fact, if you go ahead and do the division, you'll find out you get like 18.375. And if you multiply that by 10 to the power of 19, you can move this sort of decimal place back here. And because you're removing a decimal place, you add one to the scientific notation. So you get 1.8 blah, blah, blah times 10 to the power of 20. And that's why B is the correct choice. Now, let's take a look at this one here. This is a example of a moment question. This one is, not very difficult, but it requires you to kind of fully understand how moments work in order to be able to actually do it. So the thing is, they're saying how far from the other end must this 80 Newton weight be placed, all right? So like for the beam to be balanced, all right? So we're trying to find this distance here. We can call that X. All right. So keep in mind that all the moments have to be taken to this pivot here. We can consider the string to be the pivot. So every weight that you have, every force that you have, you measure the distance of those weights to the string. For example, the beam itself, which is 3 meters long, has a weight of 100 newtons. So the 100 newtons of the beam, all right, we can assume it's going to act from the center of gravity, which is going to be in the middle, and somewhere in the middle. And we can assume that the distance of the weight itself is about 0.50 meters from that string. Why? Because the whole beam is 3 meters. And the middle point is going to be at 1.5 meters, which is here. And, if you want to calculate the distance of that 1.5 meters, to the string itself, is going to be 0.5 meters. So this is going to be the force of the beam itself, which is going to be acting in the same direction as the 80 Newton force. And the other side, we have the 300 Newtons acting in the other direction. So anyways, in order to find out how far the 80 Newton weight has to be placed, the way we do it is like this. We say that, first of all, 300 has to get multiplied by its distance to the string, which is our pivot. Again, that's 0.5 meters because the whole thing is 1 meters. So if you divide that by, half, you would find that the distance is 0.5 meters. So this gets multiplied by 1/2 or 0.5, and this should be equal to the moments on the right side added together. So the 100 Newton, that's the weight of the beam, multiplied by 0.5, and that will get added to the weight that is on the right side. That's the 80 Newton weight. And the distance of the 80 Newton weight to that side has to be done mathematically, symbolically for yourself. The whole thing is 2 meters, right? So how do we know how far that 80 Newton weight is placed? Well, if the whole thing is 2 meters, if you subtract 2 by x, you'll find its distance because you kind of have to omit this part. So 80 newtons gets multiplied by that 2 minus x. That's this distance to that part. So you're going to get 150 is equal to 50 plus 160 minus 80x. Once you're left with this, if you kind of do some subtraction, you're going to get 150 plus 160 is 210, minus 210 is equal to negative 80x. And, 150 minus 210 is negative 60. And thus x is equal to negative 60 over negative 80, which will simplify to 3/4, and 3/4 is simply going to be 0.75 meters. That means the choice that is correct is A. Now, this was rather a difficult sort of exam sort of a question on moment that we had in 2013, but you have to wrap your mind around the ideas of moment. You have to do lots of practices for you to be able to handle these types of questions well. Now, let's move on to another question. This one is saying that we have two forces of equal magnitude. Which one shows a couple acting and states the magnitude of the torque, which is the moment. Okay, first of all, torque is going to be calculated usually by the formula F times D. And a couple is created when the forces act in opposing directions. So they kind of create this turning effect. That's what a couple is in general. So how can we do this one? Well, the first thing we have to understand is the only one that is going to create a couple is case A, because the forces act in opposing directions. B, we're going to actually create stress in the metal bar and probably break the metal bar. C, they're acting in the same direction, so they're not going to create a turning effect. D is the same, and actually E could be another choice. So let's find out whether it's actually A or E. Well, it turns out that if you're going to go ahead and create a torque, you can create the torque, by simply turning around the pivot, right? So we know that torque is force times distance. But between choice A, which is saying that torque is actually F times D over 2, and choice E, torque is F times D, which one do we think is actually the correct answer? So it turns out that because the forces are going to be acting at their own distances to the pivot, we can assume that the answer to this one is actually going to be E, because there's no need to divide the distances by 2. That's a mistake a lot of people make. So you just can say the torque is going to be the force multiplied by its distance to the pivot, because each force is going to act, across the whole bar, which is D, instead of dividing D by half, because that's the main point that you have to know in this one. Now let's go ahead and take a look at 18. It says the diagram shows a horizontal beam of negligible mass, which is placed on two supports, one at each end. It has a 300 newtons weight placed 1 meter from one end and a 500 newton weight placed 1 meter from the other end. Both weights act vertically on the beam as shown in the diagram. They're saying, what are the upward forces from the two supports acting on the beam? So this one is actually also kind of difficult, but it's doable, all right? It's doable. What we have to do is this. First of all, we have to recognize there's going to be these upwards forces coming from both of these sort of pivots that are going to cause sort of a reaction force towards the forces that are going to be acting on the bottom. We know that the force created on this side, on the left side, is going to be acting at 1 meters towards this pivot. So it's going to be 300 times 1 plus the force that is going to be on the other side. That's the 500 newtons. And that force acts at a distance of approximately 4 meters. So we can say 500 times 4. And so the moment created on the left, we can say, is about 1,700 newtons. By the way, this was 500. So plus 500 times 4. So we can say that that's 700 newtons approximately, Newton meters. Now, here's the deal. How can we find the force that is going to be applied, for example, by the other forces, right? Or perhaps by the beams by the pivots themselves. First of all, you have to understand that the 300 Newton force and the 500 Newton force are the forces that are going to be there. So if we were to combine those two forces, we can call this force X and this one Y. They should add up to 800 newtons, because like 500 newtons plus 300 is 800 newtons. So that means that the forces that are going to be exerted by the two beams are definitely going to always add up to 800 newtons. And which choices do not add up to 800 newtons? You can cancel them out. So for example, we know right off the bat that, if you add 360 to that, it's going to be 600, and 600 plus 300, it's 900. So E is canceled. What about A? Well, A can work because it adds up to 800. B adds up to 800. For C, again, we get, it could add up to 800, so it works. So it's, between A, B, C, and D. But how do we exactly find which choice is the correct answer? So what you have to do is this. You have to understand that the force that's going to be exerted by one of the sides, the force that's, for example, going to be exerted by this side, by this pivot, is acting at a distance of about 5 meters to the moment that's going to be created. So we can say that this force, which we can call that force Y, is going to be multiplied by 5. And the moment that it has to support is 700 meters. So 5Y can be made equal to 1,700. And if you divide both sides by 5, you can find that Y is approximately 340 newtons. And thankfully, you don't have to go ahead and find the other force because the only one that has that force is A. And so all the other choices are ruled out. So technically what we did, and what you only have to do from the beginning, first understand, add the two forces acting in the same direction, they add up to 800 newtons. Any choice that does not add up to 800 newtons, you automatically can cancel. After that, you can find the I guess you can say counterclockwise moment, which is the 500 newtons and the 300 newtons moment, and acting on this pivot here, on this sort of the last pivot. And then you can see that they add up to sort of the moments that they create is going to be 1700 Newton meters. So the pivot on the first side, this side, we can call that pivot 1, has to balance that moment out. And because it's going to act at a distance of 5 meters to the other pivot, you can put 5y, which is its distance, multiplied by the force, which is y, equal to 1700. And you'll find that the force that is going to be supplied by the first pivot is 340 newtons. All right, thank you for watching. Best of luck. I'll see you in the future, and don't forget to subscribe so you can help me out as well. Bye-bye for now.